In November 1999, our client Omri was crossing the street to deliver a gift to her neighbor when she was hit by a pickup truck, leaving her unconscious with the 5% chance of survival. After 2 months in a coma, Omri miraculously recovered. She now has severe tremors. Her tremors increase in severity as her arms move away from her torso and when she focuses on performing a task. Also, Omri is unable to control the force with which she grasps or holds objects, meaning her hand can either be opened or clenched tightly. Our team began the engineering design process with a search for patents similar to what we had in mind. We discovered devices used to enable people with disabilities to feed themselves, similar to our final tabletop device, eating utensils similar to those used in the tabletop system, and writing aids that use the same concept of magnetic resistance to reduce tremors while working over a flat surface. Prototype 1 focused on providing resistance to Omri's clenching with an over-the-hand device consisting of hinges and springs. Unfortunately, even with additional resistance, this device was not strong enough to prevent clenching. Also, the wood springs and hinges were uncomfortable, and the means for attaching it was difficult to implement due to her tremor. Prototype 2 is the smaller version of Prototype 1. The metal provided for better dexterity, but could use more resistance. We then moved on to Prototype 3, a device to grab a cup and avoid crushing it. This led us to T.O.N.G.S, tool offering negation of grasping and spilling. Safety measures were followed throughout the construction process. We wore goggles and work gloves when building the prototypes and had adult supervision while using power tools. We built all devices so that there were no sharp edges or projections to limit the potential for injury to the client or others around her. We also used an anti-slip coating on T.O.N.G.S to limit the potential for accidental spills. The major components in T.O.N.G.S are fabricated from sheet aluminum due to the ease of bending and forming this material. The team ultimately decided to weld the T.O.N.G.S in place due to the superior strength that welding afforded. The lacrosse glove was selected because of the longitudinal flexibility and cushioning this glove gave. Our team's device utilizes Omri's unregulated clenching, while other devices attempt to prevent clenching. T.O.N.G.S is portable and easy to use. It's as simple as putting on a glove. This can help people with tremors in the workplace not only take a drink, but can also be used to pick up items used for their occupation without clenching and with less shaking.
Okay.
I have one, actually.
While initially focused on the application of drinking, we realized that our client needed more help than simply grasping cups. We needed a means for delivering food from the table to the mouth in a smooth manner. We then created the tabletop system, a surface used on an existing table which provides the attractive force between ferromagnetic material built into the surface of the table and magnets embedded in a brace attached to the user's wrists. Tabletop system design, construction, and function. The tabletop system uses friction and the magnetic attraction between the table's surface and a magnet positioned adjacent to the user's hand to facilitate the delivery of food to the user. The system is made of multiple components, including a wrist brace with embedded magnets, a variety of food receptacles, and a tabletop consisting of a laminate of wood, ferromagnetic material, and countertop laminate. The food receptacles are formed and bent in unique manners to prevent spilling as the food moves to the mouth. We created an attachment for the wrist brace that would hold almost any utensil. Simply place the spoon or fork in the designated hole and tighten the screw on top by hand. When finished eating, simply turn the screw in the opposite direction and pull the utensil out. The tabletop system can be used to eat while at work and can provide a surface for people with tremors to sort parts more efficiently or even help them put together different pieces of a product on an assembly line. The tabletop system costs around $95 to manufacture. The tabletop would best be marketed to assisted living facilities through wholesale channels. The tabletop system uses downward magnetic attraction and resulting friction to reduce the motion associated with Omri's tremor. The magnetic attraction between the magnets in the steel and the resulting friction combine to dampen the motion from her tremor. The magnetic attraction slows both vertical and horizontal tremors. Omri found it easier to slide a cup toward herself instead of actually picking it up. We created a device consisting of curved sheet aluminum and a wooden rod to help her. Without the help of the tabletop system, Omri had a difficult time transitioning food from the table to her mouth. Placing food on a utensil was difficult and daunting work. The dishware Amr used was constantly pushed away by the agitation of her utensils. Before our design, Omri had a difficult time picking up a cup and various other items, and eating a meal without extensive help from her mother. Now, with the help of tongs and the tabletop, she can use her clenching to pick up cups and can eat a full meal without much help and with greater efficiency. Throughout research, design, and testing, our team has become more appreciative of the engineering design process. Our team has helped Omri improve her control over her fine motor skills, pick up items without crushing them, and helped her gain more independence while eating a meal.
Jonathan and Clark.